that's basically my constant struggle. And so to give you some context, right? RingCentral has customers in Europe. It has a huge customer base in EU, Australia. So we not only want to support English, but we have to support other languages, right? And we don't necessarily, the amount of traffic that we get still for English workloads is almost 10 times more than other workloads. And so, which basically, and all of these other workloads then are distributed, like you have Spanish, German, French, Italian, like these are four languages. All of these have really small amount of traffic coming in. And so for us, the constant struggle is, hey, I have one GPU. I don't have enough traffic from each of these languages. I am not going to give each of these models a new GPU, right? Otherwise, we are just wasting GPU cycles. So a lot of our work has been on trying to sort of take a even 100, split it into like multiple sort of, uh, GPUs per se from a model perspective, and so that we can effectively run multiple types of models. But then, which also brings us to other challenges, is scaling, auto scaling in that scenario becomes super, super tricky. Like,
Hi everyone, this is Ishwarya Goyal
And I'm Nilesh Agarwal.
from Towards Scaling Inference. Towards Scaling Inference is a place where you can learn about ML deployments from zero to scale. We are very excited to have Sushant with us from RingCentral. He is an expert AI researcher and data science leader, currently serving as the director of machine learning at RingCentral, where he focuses on building next generation conversational AI platform. Previously, he was the co-founder and CTO at DeepEffect, which was acquired by RingCentral. Prior to that, he also led the data engineering team at Lumiata. Thank you, Sushant, for joining us today.
thanks guys for hosting me.
Great. So, Sushant, to begin with, would like to understand that what kind of business problems are you solving through AI?
Yep, so RingCentral is a UCaaS CCaaS provider. So we basically work with phone, meeting, the whole stack. So my team is specifically focused on improving meeting experiences. And we basically started during the hybrid work sort of scenario. So, right during the COVID timestamp. So what we've been involved in is adding various AI filters to our meetings, and how do we sort of get from a standard meeting experience where you get fatigued to all the way till how do you sort of extract out as much info as possible from there. So we work on entire suite of products which power AI into different things like live transcription, translation, and then summarizing meetings, the whole stack. That's what me and my team work on.
Interesting. And how do you currently deploy your models in production? So, do you work with like managed services in the likes of AWS SageMaker, Hugging Face, or have you built your own ML infrastructure from scratch?
So we have a completely in-house infrastructure. We have like a separate infrastructure for training large-scale models, and then we have like a separate sort of infrastructure for inferencing pipeline. All of this is built on top of Kubernetes, and yeah, so we were one of the early adopters of ML ops, and yeah, so it's been an interesting journey for us.
Got it. Got it. Oh, that's super awesome. So just wanted to understand again, as you guys are deploying your production infrastructure in Kubernetes, right? How has that experience been, and what are the like challenges in terms of especially utilization of resources there? Just wanted to understand that part. Yeah.
Yeah, so since we built the whole sort of deployment process all the way from building and deploying into production from ground up, it's been an interesting journey, a lot of learnings, a lot of challenges along the way. And over time, we have made a lot of optimizations on how we push things into production, and whether it be starting from as simple as model versioning to all the way to how do you effectively monitor models, right? So there's been a lot of work on that front. But in general, challenges we've faced quite a few, both in terms of how do you scale up the workloads based on the traffic, how do you effectively use GPUs so that you can squeeze as much juice as possible from every single GPU that we have out there. And then there's also been an interesting sort of a lot of benchmarks that we have done is how do you effectively deploy models, like whether it makes sense to run on a GPU, whether you want to run it on a CPU. And so, yeah, that's basically some of the things that we constantly dabble with. Since we also work with a wide variety of data, um, model monitoring in itself is a pretty interesting challenge for us. It's not solved by any line, but we are sort of spending a lot of our energy nowadays on making sure we not only just monitor the health of AI models, but how do you make sure AI models are constantly state of the art? How do we keep making them better over time? Yeah.
Got it. No, I think the whole pipeline, I think thanks for giving us like a bird's eye view. So I think I just found that there are 3 or 4 different parts of the pipeline that again you guys have successfully built there, right? So just wanted to dive deep into each of the pipeline, right? Starting from the first, which is very much the versioning and deployment and optimization, right? So just wanted to understand like how do you guys, again, you don't need to like deep dive into the secret sauce, but how do you guys think about like optimization before you deploy a model? Like what are some of the suggestions that like you can do once you have like done that?
Yeah, so a lot of these things have become much more standard nowadays, but things like quantization, default quantization was one of the things we started off very early. And there is again a lot of like trade-offs, whether you want to deploy something on CPU versus you want to deploy something on GPU. We have empowered our data scientists to sort of be at a level where they can also understand these trade-offs and they can also make those decisions. And they are the ones who kind of build the model, so they are the ones who have more intimate knowledge of how this model in general works and what could be the best way to sort of deploy them. And then there is a good sort of platform team which supports them in terms of doing a lot of these automated, I would say, optimizations to squeeze as much as performance while reducing the size of the model. That's kind of like the first part. And then second part is how do you deploy it, right? What is the mode of deployment? So for us, we kind of have different levels of workloads. We have streaming workloads like live transcription or live translation, but then we do a lot of asynchronous processing. Like once a recording is generated, we sort of want to summarize it. We do a lot of these things asynchronously. And so both of these workloads have an entirely different way of optimizations. Like for offline workload, you might be okay with slightly longer latencies, but you want to batch very effectively. On a streaming workload, you kind of want to make sure your latency is as low as possible, but still you want some level of batching. You don't want to like send one request and just run it on the entire GPU. So it's kind of like there is a lot of work that involves in how do you effectively batch requests in case of, let's say, live transcription. And then in offline is how do you sort of, if we are LLM is nowadays the craze, but we've been working on generative AI for a while. And how do you now, everybody wants to jump in on the bandwagon with ChatGPT and everything. But in general, once you have a good POC, once you find that little bit of success, a lot of work is going to be in, now I'm getting like 1,000 simultaneous requests. How do I batch each of these effectively? How do I create a summarization sort of framework on top of it? So those are some of the challenges that people will face on the the rest sort of asynchronous part of it as well. So for us, the model deployment and optimization definitely is a constant aspect, and that is never a solved problem, right? You want to squeeze as much as performance as possible. Like we are much better than what we were a year before, but if we have the same conversation next year, we'll still be even better than what we are today. So it's kind of like a constant battle that people work on. But yeah, it's and that's where the problems are difficult, so more fun to solve.
Got it. No, that's pretty interesting, especially the part where again the optimization and the quantization pipeline even differs for different kind of workloads, right? So if I understand correctly, it's like there are different like types of tasks. Some are like more real time, some are more batch, and based on the type of the job, there's also like a different type of quantization or GPU or memory support that you give those kind of tasks, right? Is that a correct understanding?
Correct. Yeah. So in terms of like even on which type of machines you are running them, right? So some of these tasks could be very memory intensive, but might not necessarily need that much CPUs. Or even when you're running workloads on GPUs, you have a lot of pre-processing, you have a lot of post-processing. You don't necessarily want to run everything on GPU. That's like waste of GPU time or GPU cycles. So you want to create that effective pipeline where you kind of need to figure out which which sections of your pipelines make sense on which type of like underlying hardware, and sort of a lot of work will then become very specific in terms of what do you do on CPU versus what do you do on GPU, or are you able to do everything on CPU?
Got
So
it. And also, does networking also play a very critical part in like managing the Kubernetes? Let's say how the data flows from like pre-processing to the mains, let's say the predictor pod to the post-processing. Like, what have been your learnings in that part of the pipeline, right? So how critical is that, and like how does that affect latency?
yeah, that basically, so I've been fortunate to have a pretty solid like ML ops team. Like they were not ML ops per se, they were like really good DevOps engineers who have battle tested Kubernetes, and we sort of groom them towards the whole ML ops infra. And in general, while we have a very solid system running nowadays where we have squeezed performance as much as possible, both in terms of latencies from every step of the pipeline, there is still a lot. So if you take example of like async workloads, you have a lot of queuing time. A lot of time requests are just queued inside Kafka. They're waiting for some of these pods to come up and process them. So that's where we do a lot of optimization, and that's where a lot of time is spent in terms of how do you effectively auto scale each of these. Because at the end we are trying to maintain some level of SLAs, and different workloads have different levels of SLAs. Some of them are not customer defined but internal defined because we want to give amazing experience. So if you want to look at a meeting summary, you don't want to wait like 2 hours for the summary to come in. By that time you're already in next meeting. So you kind of like, there is like an optimum product experience, and to drive that product experience, you want to make sure your AI services are able to generate those within the required sort of time, right? And so that's where we faced a lot of challenges, as well as because every model has its own latencies per se, and scaling every model itself is not as straightforward as every other model. So you have different types of models. Scaling transformers could be a different task than scaling, let's say, something like a CNN model, just an example. But so because they have a different way of mechanism. And so, yeah, but the way what we have done now is we have been able to abstract out a lot of these things. We have abstracted out, and every model sort of pushes their metrics to Grafana. Like all of these model monitoring metrics are being pushed to Grafana, which is then being used to auto scale a lot of these. So now we started off with something very ad hoc, and then now we have come to a point where it's much more specialized, in the sense that a lot of things happen manually, which used to happen manually are now automated to the point where you just need to look at alerts. You don't even need to worry about anything else. So
Got it, got it. And last question before I hand it over to Aishwarya. So, in terms of Kubernetes, right, especially when you're working with GPUs, since it does not come up with like native support for, let's say, memory sharing, so how have you guys been able to like do that on Kubernetes? Let's say, like use the same GPU to run multiple models and all those things. We just wanted to like have a 100-feet view on
yeah,
that.
and that's basically my constant struggle. And as so to give you some context, right, we RingCentral has customers in Europe, it has a huge customer base in EU, Australia. So we not only want to support English, but we have to support other languages, right? And we don't necessarily, the amount of traffic that we get still for English workloads is almost 10 times more than other workloads. And so which basically, and all of these other workloads then are distributed, like you have Spanish, German, French, Italian, like these are 4 languages. All of these have really small amount of traffic coming in. And so for us, the constant struggle is, hey, I have one GPU, I don't have enough traffic from each of these languages. I am not going to give each of these models a new GPU, right? Otherwise, we are just wasting GPU cycles. So a lot of our work has been on trying to sort of take a E100, split it into like multiple sort of, uh, GPUs per se from a model perspective, and so that we can effectively run multiple types of models, but then which also brings us to other challenges is scaling, auto scaling in that scenario becomes super tricky. Like it's okay if it's just one GPU, you can split it as much as you want, but once you want to auto scale, then how do you auto scale at that point? Because let's say you just have French workloads coming in, not German, then when you get in the next GPU, are you sort of deploying all French, all German? Like those are like very difficult decisions that need to be made, so that we, at the end, it's all about infrastructure cost, right? You don't want to waste all of these infrastructure cycles, because bringing up GPU and bringing it down itself takes so much time. So you kind of need to warm some of these GPUs up before they come in, while you still want to make sure it's a fine trade-off, right? You don't want to give so much poor latency that customers will stop using it, but you don't want to sort of support that. You don't want to end up spending like 10 times more than what you would have otherwise spent. So, but yeah, we work closely with NVIDIA, and we are one of the biggest partners of NVIDIA on this front as well. And we've worked with them on optimizing a lot of this stack, but I would say we are still far away from where I want to be. And yeah, that's basically one of the interesting challenges that we are working on.
Awesome.
Got it.
Awesome.
Very interesting. I think so. The next thing we would love to understand is that what do you feel are the implications of the infrastructure cost on your business outcomes? Like, do they limit you in terms of experimenting with more models, growth, etc.?
So for us, what we've done is we have split training infrastructure cost versus like inference pipeline infrastructure cost. And inference pipeline is tied back to like the product, like uh, as long as we are making, as long as the unit economics make sense, it is still okay. Like you can scale up, but only to a certain point. And so that's where we do on the inference side. For training, we kind of have a different way of looking at it. That's our experimentation workload. So we don't want to limit people in terms of the number of experimentations they can run, but again, it's a huge team, and a team with very different types of like experiments running. Like computer vision team has something different, whereas speech, where you're training a new speech to text model, which takes like a lot of time to run. So we have like a dedicated we have a couple of dedicated MLOps guys who effectively are working on how do we share this training platform, so that there is not, you have to wait, but there shouldn't be so much wait that it's bottling, hampering your productivity. Like you're not able to train models. So we basically work with NVIDIA DGX clusters, and we have a big setup on that front to train these models. But yeah, so in general, it's sharing, it's based on like you get some time on this server and on this platform, and then you kind of run your experiments, and then you get the results back, and then spend some time analyzing while you request like a new job. So we have like a certain set of things, and that's kind of where my role is to make sure we provision enough based on how much capacity we can get, and so that it's kind of like a fine balance. You don't want to overbuy at a point where it's not being used, or not being used for interesting enough items, but you don't want to underbuy to a point where your team is just sitting doing nothing. They're running workloads on their laptops and like taking forever. So it's kind of like a good balance, but yeah, it's a very interesting challenge to solve for. And
I'm
as
sure.
and fortunately, we are at a very interesting time. We have generative AI, which is like every new day there is something crazy going on. And so with all of this hype, it also brings a lot of new avenues of using AI into problems which people thought previously were not possible. So yeah, so which again makes my job difficult, is now I need to figure out how to get more, how do I squeeze in more performance from whatever infra we have already. So
Yeah. I'm sure. Definitely an interesting challenge to solve. Just the last question, Sushant. So, can you discuss any best practices or tips for other ML engineers, practitioners looking to deploy a model in production based on your experience?
yeah, definitely. So, it entirely depends on what stage of AI maturity a company is at, right? See, if you are a ML engineer at an early stage startup, then your goal should not really be trying to optimize a pipeline and use Kubernetes and all that. It's just like waste of your time and energy. You kind of should need to focus on, hey, as long as I'm able to get my model serving pipeline up, and as long as I'm able to serve my traffic, that should be your primary goal. But as your team goes through maturity, you kind of want to spend more time not just looking at, hey, are we able to deploy properly, but more in terms of monitoring. A lot of times GPUs get stuck, and we sort of notice this, like we had behavior only when we started monitoring, is sometimes you're not able to squeeze in performance, and then you start looking at the logs, and then you figure out, oh, this pod was just sitting idle for a long time. What happened? Oh, something happened on the GPU and it got stuck. It went into inconsistency. You'll start noticing these weird problems at scale when you're trying to max out performance from each of these steps. So then I think even in terms of ML monitoring, start off with something very rudimentary, which is like, how would you monitor a software stack? Start off with the basics, like just monitor CPU, memory, just monitor how many requests are coming in, going out, what is the latency. Start there, and then as you move forward, try to bring in the fancier things which we keep hearing in model monitoring communities, data drifts, and all of it. All of this is great to have, but in reality, if you don't know how to interpret each of these graphs, kind of doesn't really make sense. Like, you wouldn't really, unless these are actionable items where you understand that some drift is coming, and but you don't know what to do with it. It's kind of like, it's good to, you are not really able to do anything with it. So you at least understand, and then sort of figure out what is the next step from there. If you understand there is some level of drift in your data or your distribution, then you kind of need to, let's say, retrain your model, or maybe change something on your pipeline, or pre-processing broke, post-processing broke. So that way you can sort of take these gradual steps, and not necessarily everything is needed on day one, but don't do anything is also not a good idea. So start with bare minimum, and slowly over time, as your team grows, as maturity inside the organization grows, keep on adding this additional level of stacks, which can help create a more formidable AI pipelines.
Great. No, this is a great, great kind of feedback, and I think this will really help other MLM engineers who are in the process of deploying. So thank you so much, Sushant, for joining us today. It was really fun to understand about your journey and how you are dealing with all the challenges and the new initiatives. Thank you so much.
Awesome. Thank you.